Okay, Assalamualaikum and hello everyone. So today we are going to continue with the rest of 4.1. Okay, so for this week we will learn how to draw Lewis structure of our covalent species with a single, double and triple bonds. And then we're going to compare the bond lengths of those single, double and triple bonds. Later we are going to determine how to count the formal charge of the atoms in our compounds. Okay, and from there we are going to be able to determine the most possible Lewis structure. We are also going to learn something that applies to certain elements. Okay, it is the exception to the octet rule. So we have the octet rule, the three rules, right? But there are certain elements that will not follow the octet rule. Okay, so the rules that will apply to them will be elements that form incomplete octet, expanded octet, and odd number of electrons. Okay. Finally, we are going to illustrate the concept of resonance using appropriate examples. So resonance ni kita just gerak-gerakkan the bonds lah. Okay. Alright. So first of all, what is Lewis structure? So Lewis structure is actually a structure which tells you how we arrange or where we put the valence electrons in the molecule. So before this, we already have Lewis symbol, and that's specific for atoms, right? But now in Lewis structure, we can put the valence electrons in our molecule. Okay? So this Lewis structure is very important for us to predict the shape of our molecule later. So in this chapter, okay, Lewis structure, shape of molecule, and then later orbital overlap. Okay, it is very correlated to each other. So if you get the Lewis structure wrong, you will get the others wrong. So this is very important, alright? This is a very basic foundation that you need to be strong in. Okay, so let's look at the steps on how to draw our Lewis structure. So there are 5 steps. So we will start with first counting the total number of valence electrons. So if you have ions, alright, then you will add 1 electron. If you have a negative charge, you will subtract 1 electron if you have 1 positive charge, macam plus 1, okay, H plus and H4 plus, okay. And second, you will draw the skeletal structure. Okay, let's say you have NH4, then that means that you will draw NH, okay, around it. Okay, but then how will you know which element, which atom will be the central atom and which atom will be the terminal atom? So central atom is the one that will be in the middle. It will be the least electronegative atom atau most electropositive atom. Okay, and then a general rule that you will apply is also that hydrogen atom will always occupy terminal atom, will always be the terminal atom, maksudnya yang dekat tepi. Okay, kat tepi, besides dah, bukan kat tengah. And then after that, you will draw a single covalent bond between your central atom and the surrounding atom. So maksudnya kita akan letak bond lah. Okay, single bonds. So this means that you already use 4 bonding pair electrons. Okay, I will be using bonding pair and lone pair atoms and electron pair atoms in this chapter. Okay, next you are going to complete an octet for all terminal atoms. Okay, duplet if you have hydrogen atom. Alright, so maksudnya cukupkan 8 elektron for your terminal atoms atau 2 for hydrogen specifically. And then tengok if you have any remaining electrons, okay, then you will put it on your central atom. If your central atom is not octet, okay, even though you already use all the remaining electrons, okay, tak cukup elektron dia, then you will need to form multiple bonds. Multiple bonds maksudnya macam double bond atau triple bond, okay, paling-paling pun. Okay, so if you put multiple bonds, then you're basically using the lone pair from your terminal atom, okay, to convert it into a bonding pair with the central atom. So maksudnya contoh macam ni, carbon, nitrogen, okay, nak cukupkan 8 elektron around carbon. Contohnya, you will use this lone pair and convert it into bonding pair. So, apa akan jadi? Ini akan hilang dan awak akan ada double bond kat sini. Macam tu, okay? So, then now we have lah 1, 2, 3, 4, 5, 6, 7, 8 electrons around carbon. Okay? So, carbon has a total of 4 bonds around it. Finally, this is important, you will check your formal charges. Okay? Formal charge is important for you to make sure you are drawing the most plausible Lewis structure. Okay? Alright, so let's look at our example. Okay, how are we going to draw Lewis structure of the following compounds? Let's start with hydrogen fluoride. Okay, so first you look at your compound and then you have to remember the groups of your elements. So you have one hydrogen and you have one fluorine and you have a zero charge. Okay, so hydrogen is in group 1, so it has 1 valence electron. Fluorine is in group 17, so it has 7 valence electrons. And this molecule is neutral, so it has 0 charge, so 0 electrons. So total up the number of valence electrons, we will get 8 electrons. Okay, so that means that we have 8 electrons to be distributed around your hydrogen fluoride. So now we are going to write down HF. Okay, this one we are going to form the skeletal structure. So then we are going to put our one bonding pair. Okay, so from here, from the total number of valence electrons, you know that you have 4 electron pairs. Okay, because you have 8 electrons, 8 bagi 2 dapat 4 lah. So one of the electron pair you will use as one bonding pair, okay, which is this one here that I drew just now. So the rest will be your 3 lone pairs. Okay, so I'm going to put my lone pairs on my terminal atom, which is fluorine in this case. Okay, so 1, 2, 3 lone pairs, or basically 6 electrons around fluorine. And hydrogen already has 2 electrons here. So if we count, okay, to check whether the formal charge is already 0, dia kena cukup electron. Hydrogen must have 1, fluorine must have 1, 2, 3, 4, 5, 6, 7 electrons. So cara kira dia, hydrogen 2, okay, fluorine 1, 2, 3, 4, 5, 6, 7, 8. So dah complete octet and duplet for fluorine and hydrogen respectively. So this will be your Lewis structure for hydrogen fluoride. Okay, so CHCl3. Okay, let's try doing that. We have 1 carbon, 1 hydrogen, and 3 chlorine, and no charge. Okay, so carbon is in group 14, so it has 4 valence electrons. Hydrogen is in group 1, and we have 3 chlorine. Okay, 0 charge. So the total will be 26 electrons. So 26 bagi 2, you will get how many electron pairs? It will be 1, 3 electron pairs. 13. Okay, so now we're going to draw the skeletal structure. Okay, how to know who will be central? Okay, hydrogen will always be the terminal, so that means that it will be here. And then are we going to put carbon or chlorine as the central atom? So carbon is more electropositive than chlorine, so that means that carbon will be in the middle. It will be your central atom. So we will have chlorine as terminal atoms. Okay, so now you are going to draw the bonding pairs 1, 2, 3, 4. So that means that you have used 4 of your electron pairs as bonding pairs, and the rest will be your apa ni, lone pairs. So berapa? 13 minus 4, you will be left with 9 lone pairs. Now these lone pairs, we will use it to octet our terminal atom. So hydrogen is already duplet. Okay, 1, 2. Our chlorine is not yet octet, so you are going to put your lone pairs around chlorine. So we have 9 lone pairs. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so if we check, okay, our chlorine already has 1, 2, 3, 4, 5, 6, 7, 8 electrons around it. So each of the chlorine sudah octet, hydrogen dah duplet. Alright, so check also our central atom. Central atom, the formal charge will be the number of valence electrons it has. It's supposed to have, it is 4, minus how many electrons around it? Count the bonds, 1, 2, 3, 4. So 4 minus 4 is 0. So our central atom already has 0 formal charge. So with that, that means that our Lewis structure for CHCl3 is like so. We don't need to form any multiple bonds. Alright? Okay. So this one, I think you can try it on your own. Now I'm going to show for this one, but I'm not going to complete it. Alright? Or am I? I think I will. So let's do this example for NH4 plus, the Lewis structure. We have 1 nitrogen and 4 hydrogen and 1 positive charge, 1 plus 1 charge. So nitrogen is in group 15. Okay, so we have 5 electrons. Okay, hydrogen, we have 4 of that, and we are going to minus 1 electron because we have a plus 1 positive charge. So 4 plus 5 is 9, minus 1 is 8. So we have 8 electrons to distribute around NH4 plus. So between nitrogen and hydrogen, hydrogen will be the terminal atom because hydrogen is always the terminal atoms. Okay, so we're going to draw that. And then we are going to draw our bonds. So we have 8 electrons, that means we have 4 electron pairs. Okay, if we draw our bonds, 1, 2, 3, 4, we've used up 4 of the electron pairs as the bonding pairs. So do we have any more electrons left? No, okay, we don't have. Alright, so don't forget that we have a plus 1 charge here, so make sure we draw that. Okay, plus. Okay, let me just kecilkan sikit. Alright, so now we're going to count the formal charge. Okay, hydrogen is in group 1. Ni formal charge untuk hydrogen. Tolak dengan berapa bond dia ada, berapa electron around dia. Ada 1 je, that means tolak 1. Okay, lone pair tak ada, so tak payah tolak, so equals 0. So hydrogen awak semua 0 formal charge. Nitrogen pula, okay, nitrogen, let's change colours. Nitrogen pula, okay, the formal charge yang ni nak kira, it is in group 15. So berapa valence electrons? 5. Tolak dengan number of bonds around it. 1, 2, 3, 4. 4 bonds. Okay, any lone pairs? Any lone pairs around nitrogen? No, so 0. So tolak 5 minus 4, it will be plus 1. So obviously your nitrogen has a plus 1 formal charge. Okay, so because of that, bila ada 0 plus 0 plus 0 plus 0 plus 1, then the overall charge for your molecule will be plus 1. Okay, so that is the Lewis structure for NH4 plus. Alright, okay, Next, we're going to look at our bond lengths. Okay, so your covalent compounds, it can have three types of bonds. Dia boleh ada single bond, double bond and triple bond. Okay, so the bond lengths for your different bonds ni will be different lah. Okay, so this is an example for single bond covalent compounds. Okay, you have Cl2 gas. Here we have oxygen gas and nitrogen gas. Okay, so Cl, it can form single bonds. Your oxygen can form double bonds. Can form double bonds. Single bond pun dia boleh. Tak boleh. Okay, boleh. Tapi dia sebaiknya double bond. Nitrogen sebaiknya triple bond for it to be neutral. No charge. Okay, so the bond length for your single, double and triple bonds are different lah. Dia macam getah. Okay, so lebih banyak ikatan, the more the number of bonds between your carbons. Okay, for example here, the bond length will decrease. So here we can see that it is the bond length in ampere. Okay, your bond length for carbon-carbon triple bond is the least, alright, is the shortest, because the triple bond is very much shorter and stronger. Okay, when the number of bonds increase, the bond grows shorter and stronger. So you can see here the relative bond length of the bond lengths of your different bonds lah. Okay, right, now we're going to go into formal charge. So formal charge is the formal charge calculation just now I showed you, right? Okay, so this is very important for us to determine the most stable and most plausible Lewis structure. So this formal charge is the charge on a certain atom in our Lewis structure. So we have to have the Lewis structure first, and then we can count the formal charge for your atoms. Okay, so the formula is like this. So formal charge for, let's say, element X will be the number of valence electrons for element X. So maksudnya awak kena tahu awak punya element X tu group berapa, and then tolak dengan the total number of non-bonding electrons. That means that these are your lone pairs, atau berapa banyak lah electron around, bukan lone pair, the number of electrons around your X atom. Okay, let's say kalau dia ada satu lone pair, maksudnya dia ada 2 elektron around dia. Okay, so this one is 2. Okay, contoh. So if it has, lepas tu tolak lagi dengan the number of bonds. Contoh dia ada 3 bond around it. Okay, so maksudnya ini adalah 3 lah, because you have 3 bonds involved around X element in your Lewis structure. So how to know whether your Lewis structure is the most stable and most possible? We are going to look at the formal charge on each atom. If your formal charge on each atom is equal or closest to 0, paling banyak 0, dan ini adalah win situation lah untuk awak punya Lewis structure tu, dia most stable. Next is, turun bawah sikit, is that your formal charge is as small as possible. Okay, and then turun bawah lagi is your negative formal charge. Let's say -1 atau -2 formal charge is on the more electronegative atom. Contohnya macam oxygen, Cl, fluorine. Okay, electronegative atom. The more electronegative atom will bear the negative formal charge, and the positive formal charge will be on the more electropositive atom. Okay, so these are the characteristics that you have to analyze on your Lewis structure lah, the formal charges, to know whether it is the most stable or the most plausible. Okay, Maksudnya itulah Lewis structure of your compound, right? So, let's say for this molecule COCl2, okay, this is very important. Pernah keluar dekat dalam PSPM lepas, okay. So, COCl2, saya dah buat sampai this step, 24 electrons. So, the next step for Lewis structure kita draw is to write down how many electron pairs we will have. 12 electron pairs. And then we have carbon. Okay. Lepas tu oxygen and Cl. So who will be your central atom? Most definitely will be carbon, because carbon is more electropositive banding dengan oxygen and chlorine. These two are more electronegative. So carbon will be our central atom. Okay, so I'm going to put it like so. Okay, and now I'm going to put my bonding pairs. 1, 2, 3. So I've used 3 bonding pairs. Okay, and then I'm left with 9 lone pairs. Now I'm going to put my lone pair. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, but if you look closely, right, your carbon has not reached octet yet. It's not octet yet. Okay, so that means that we will have to use the lone pairs, okay, from chlorine or oxygen to form a multiple bond with carbon. Okay, supaya carbon ada 4 bond and 8 electrons around itself. So there are two possible structures that we can form. Okay, so we can have this structure. Astaga, let me just copy this. Okay. Alright. So, we can use the lone pair on chlorine to form the bonding pair, to convert it into bonding pair. So, this is this is one structure. Okay, so this is structure 1. And the second structure, we can use the lone pair on oxygen to convert into a bonding pair. So now your carbon has 4 bonds around it. So in order to predict the most plausible structure, we are going to count the formal charge. Alright, so how to count the formal charge? Carbon is 4 valence electrons. Okay, look here. So it has 1, 2, 3, 4 electrons around it. Okay, so that means that 4 minus 4 will be 0. Okay, so that's how I count the formal charge. Chlorine pula, okay, it is in group 17. So it has 7 valence electrons. Tolak dengan 1, 2, 3, 4, 5, 6 electron. So 7 minus 6, it will be plus 1. Okay, plus 1. So that chlorine has plus 1 charge. This chlorine pula berapa? It is 7 valence electrons. Tolak dengan 1, 2, 3, 4, 5, 6, 7. So 7 minus 7, it is 0 for this chlorine. So this one will be 0. Oxygen tu pula, yang ni, oxygen has 6 valence electrons. Tolak dengan 1, 2, 3, 4, 5, 6, 7. So 6 minus 7 will be minus 1. Okay, so that is the formal charge for your atoms in structure 1. So on your right pula, okay, I will just write down the formal charge. If you count, okay, for oxygen, 6 minus 1, 2, 3, 4, 5, 6, that's 0. For carbon, it is 4 valence electrons, tolak dengan 1, 2, 3, 4. 4 minus 4 is 0 as well. Okay, chlorine pula, it is 7 minus 1, 2, 3, 4, 5, 6, 7. So 0 juga. Okay, chlorine bawah tu pun 0. Okay, so maksudnya for this structure, okay, all your atoms have 0 formal charges. Alright, so this is structure 2. So now that we've count our formal charge of our Lewis structures that's available, so these 2 Lewis structures, to predict the most possible structure, we can conclude that, okay, structure 2 is the most plausible structure because it has 0 formal charge on all atoms. Okay, so that is how you predict the most plausible structure. So maksudnya inilah structure yang terbaik untuk Lewis structure awak. Okay, so this is the Lewis structure that you will use. Alright, so next, it says that the sum of formal charge in a Lewis structure must equal 0 for a neutral molecule. Okay, so like PaCl3, the formal charge will be 0 overall. So if you have ions macam NH4+, yeah, okay, your polyatomic ion, for NH4+, the formal charge is +1 because it has a plus charge here. Right, so for this example, okay, we have 3 structures of SCN. Structure number 1, structure number 2, and structure number 3. Okay, so ini saya dah draw the Lewis structure. Awak buatlah step by step. Okay, next B, dia kata predict the most plausible Lewis structure. So for this one, you are going to find the formal charge. Okay, and then you are going to find the formal charge for each of the atoms in each of the molecule, each of the Lewis structure. Okay, and then you will find that the most plausible structure is jawablah. So because the formal charge of each atom is closest to 0. Okay, so buat yang tu sendiri.